concrete not compacted properly, not cured properly. Those kinds of errors, the software can't do anything about it, right? So you say, oh, I thought my propagation period through the software was 10 years, but my bridge started corroding in 3 years. That software can do nothing about it. They are expecting a good quality concrete to be placed, and then doing the calculations on good quality. See, nobody can give ranges on the quality, right? Other questions? Yes. Yes. You reduce the time. Yeah. So ultimate strength will not be reduced by about 50%. That depends on it depends on what kind of concrete you have. You asked me why is the strength dropping? Yeah, the strength is dropping later on for several reasons. One is that you have, through accelerated hydration, created quick reaction products. You made it so quick, you made it so fast that they start deteriorating after some time, right? So your reaction product, see, anything that is natural. Now think about the rocks, the sedimentary rocks and the metamorphic rocks that formed over a period of millions of years, and they're very strong, right? Can you take all the components of that rock, put it in a strong press and create that same effect in 6 hours? No, right? So time is a factor in any chemical reaction. For our convenience, we accelerate it so that we can get it done quickly. It's a prediction tool. It's also, for precast, they accelerate it. So you do it, and then if you accelerate it, you will have reaction products becoming unstable later. I'll give you an example. Ettringite. You have ettringite very early on in your concrete, and then you transform that ettringite to monosulfate. But if you have certain chemical compositions, typically certain type of sulfates, and if you have gypsum not completely utilized in your hydration reactions, certain type of sulfates, in the normal ambient conditions, that sulfate is going to do nothing. It will just stay there as sulfates, SO3 2 minus. It will move, you can move on, and the concrete will be okay. But if you have ever accelerated cured that concrete, the sulfate will be part of the gel structure, because you have made it so fast. Your heating was there, so all these ions are randomly moving around. There's a lot of Brownian motion that you can't control. So the sulfates will be part of a gel structure, and then after a long period of time, gradually when the structure starts to decompose, sulfate will be released. But then at that point of time, if there is some alumina hanging around, which there will be, because you did accelerated curing, your cement is not completely hydrated, your alumina reaction is not really taking place in accelerated curing. Because see, if you look at the cement reaction, I showed you those pictures, what is the first thing that reacts? C3A, alumina. Then C3S reacts. But what do you want to react fast to get strength? C3S. The moment you give heat, alumina says, okay, I'm going to sit back because the other guy is going to react now. There is an internal adjustment between all of them. You give heat, alumina says, okay, I'll keep quiet because my reaction is supposed to be the one that's first, but because you want C3S to take over and give you strength, I'll let him react. Alumina is sitting quiet, right? And then there is sulfate and alumina. Think about 10 years down the line, sulfate and alumina in your cement. What will you form? Ettringite. What happens if you have ettringite and then some moisture coming in? Ettringite will expand, cracks, right? So you don't have to have complete deterioration. You can have only very small cracks to form strength loss. That's why. And there are several mechanisms. This is just one delayed ettringite formation, just one mechanism. But there are several reasons why for elevated temperature curing, you will have loss of strength. But if you do a precast concrete, you can afford to have that loss of strength, because you always get way more strength than you actually want in the final place, right? So you can afford to have that loss in strength. That's why they do this. If you do pre-stressed concrete, you account for that strength loss you account for creep in pre-stressing, you account for all of that to account for later age stages. So, you do that in your design. Any other questions?